Welcome to Developer Ramp Up, a channel dedicated to anybody who wishes to become a software developer or a better software developer. In this video we'll talk about strings, and you will probably say, hey, strings are easy, they are just some words or a sequence of characters, so they are easy. And you might be right, strings are not necessarily complicated. However, I witnessed a lot of misunderstandings and misconceptions about strings, specifically when you put them into the context of value types and reference types in .NET. And on value types and reference types, we did a separate video on Developer Ramp Up, and I strongly encourage you to check it out first before going further with this video, because we'll make a lot of references to the code that we wrote in that video and to the concepts that we discussed there. And especially if you're not familiar with value types and reference types in .NET, please check that video out first. Let's come back to strings now. They are really important because we use them really every day, so we have to understand how strings work. And therefore I try to articulate this video around some very important facts about strings that you should really take note of. And the first important fact is string is a class and therefore a reference type, and this means in turn that the value of a string variable will always be the reference to the place in memory where the string resides. And this might, however, cause a lot of confusion because the way strings are declared and initialized. Let's, for instance, take a normal class, like the string builder class. So how we usually do that? We declare a string builder variable SB, and it would be equal to new string builder, and that's it. We have declared a new string builder variable, we have instantiated a new string builder object that resides, of course, somewhere in memory, and SB, our variable, holds a reference to the place in memory where the string builder object resides. So very simple. Now if we declare a string like string something and equals to something, let's say. So this is how we declare the string. We didn't use a formula like new string or something similar. We just declared the variable of type string and then assigned a value, a string value, to this variable. Now if we, for instance, want to declare an integer number which would be equal 5, we will note that integers are declared and instantiated in a similar way. And this is where a lot of the confusion comes from, because a lot of people may think, okay, if a string is declared and initialized similar to the way an integer is declared and initialized, this would mean logically that string and integers are very similar. And in fact this is very wrong, because string is a class and therefore a reference type, and int is a struct and therefore a value type. And they really behave like value type and reference types, no exception to that. So the fact that we declare a string variable and initialize it similarly to the way we do this with an integer really doesn't make strings and integers to be similar. In fact, they remain still very different, and this is really important to note. Now, of course, you might ask yourself, okay, but how comes that we can declare and initialize a string directly with the value? And the answer to that question might be a little bit complicated and tricky, and that's why I would like to look into a code sample, into a custom class that behaves similar to the string class. And I wrote already the code, and I will bring it to the screen right now, and then we can discuss it. So here's the class. It is a custom class called email address. We have a private read-only field for this class, a constructor that takes in a string, and it sets the private read-only property to the value of the string. And then we have two very strange methods, and we see that these are implicit operator methods. Now the implicit keyword is used to define a user-defined type conversion. So it basically takes a type and in converts it into some other type. And the implicit keyword means that we do this implicitly without the need for the developer to also declare a cast when we do that. And the logic behind is to generate a class that really behaves very similar to a string when we declare and instantiate it. So let's check it out. Let's declare a new variable of type email address, which is our class. Let's call it EA, and we will here write a string something at something.com. So you see we did not provide, let's say, the normal object instantiation with new email address, but we declared directly, or we initialized this email address variable to a string which is something at something.com. Let's now try to print this to the console. And once again, when we print this to the console, we will print the variable. So we won't use any other property because we don't have any properties in this class. And the field is, however, private and read only, so I won't be able to see it in the static void main scope. Let's also add a console read line, and this is used to make sure that the console will remain open after the output is displayed. And let's now run this program and check out what we will have to the console. And as we see, we received something at something.com. So that's very, very cool. We see that we have declared and initialized this EA variable basically exactly the same way that we declare and initialize a variable. What happens behind is that when I do this, so when I do this initialization to this something at something.com, it will hit these implicit operators. And first it will take this email string that we provided here, and it will create a new email address object providing this email string, which is exactly the way we defined our constructor. And then the constructor sets the private read-only field, my email, to the value of the string that we have received. Now, when we print this to the console, what happens is the exact reverse. It would take an email address object, this implicit operator, and it will return a new string which will be the my email field, which in turn will have as value the string that we have provided when we initialize the string. Now I have oversimplified what happens in background when we declare and instantiate this type of class, but let's say this is the big picture, and normally this is the way how this works. I really don't say that exactly the same thing is implemented also in strings, because it is not. What I wanted, however, to point out is that we were able to create our own class, and we were able to make our own class behave very similar to the string class when we declare a variable and initialize it to a certain value. But this remains still a variable of type email address, so it is a reference type, and what this variable holds is a reference to a place in memory where this email address object is stored. And that's exactly what happens also with strings. And that's why, even if we use a similar way to declare and initialize strings with the way we declare and initialize value types like integers, they still remain different. String will remain a reference type because it's a class, and integer will remain a value type because it is a struct. Now let's go further to another very important fact about strings that I really want to point out right now. Strings are immutable. Yes, you heard correctly, strings are immutable. And this means that they are read-only and they cannot change. And you will say, hey, that's not really true, because we are certainly able to change the value of a string. And for instance, if we, let's say, string something equals something, let's also type it correctly. Okay. And then if we do something equals else. Let's do it like that, and let's print something to the console. In fact, you see that we don't have any errors here, no red squiggly lines, nothing. So everything seems to be okay. Let's also add a console read line here, and we should be good to go. If you run the program, of course, we will have to the console the value else, because we have first said string something equals to something, but then we said something equals to else. So we would say, okay, but we have changed the value of this string, of this variable. However, this is really not completely true, because what happens in background is that we have a new string object. So this means that the original string that we declared here basically was pointing, or the value of this variable was pointing to a place in memory where we had a string object that contained something. Now, when we said, okay, make something equal to else, so add else to something, what happened in fact here is that in background, the compiler took this something and put as value a reference to a really brand new string object that was created and to which else was added. And in fact, we can prove this also very simple. Let's have a string as str1 equals to hello, and let's have another string str2 equal to string 1. So this is a very similar exercise to what we did both with value types and reference types when we talked about value types and reference types. So in that specific video that I would encourage you once again to watch if you're not familiar with this concept. Now what we have here is a string 1 which equals hello, so it holds a reference to a place in memory where we have this hello stored, and then we had string 2 equals to string 1. So we would have two different variables that have a value, a reference to the exact same location in memory where hello is stored. Now let's do here first a console, no, don't do it. Let's now make string str2 equal, and let's make it equal to world. Now, okay, here we have to declare it without string, of course, because we have already declared the type, so that would be okay. And now let's try to print different things to the console. So first of all, console write line, what we want to print is str1, and what we want to print further is of course str2. Let's do this with copy paste, because in this case it would be easier. Not that I encourage you to use copy paste when you are really writing code. And let's get rid of the other console write line that we had here, and let's see what we get printed to the console. So let's run this program and check this out. So we have hello and we have world, and what we see here is that when we gave to string 2 a new string value, what happened is that in background the compiler created a brand new string object to which assigned the value of world. So str2 was now holding a reference to a place in memory where we had this world string. However, str1, which is also of type string, still holds the reference as value to the location in memory where we have this hello. So that's why we get this result. In fact, there is another way, or there is an additional way in which we can check this. And for instance, if we run also console.writeLine, and this time we will use str1 get hash code. Now get hash code is a method that is basically on the object type, so you could call it on really each type of object, and what it does, it gets a hash code for this specific object. Now, a hash code is normally used for easy lookups in lists, in arrays, and so on. However, another use of this get hash code is to check if two objects are exactly the same, because especially when we are in the same scope, because we are in the same method here, normally if we run this get hash code on two different objects or on the same object, it should, however, display different hash codes, of course. And if the objects are equal, it would display really an equal hash code. And let's also maybe try here to add a new, let's make this str2, of course, and let's add a console write line str and get hash code after we declare this string here, so that we can check exactly that the hash code for str1 remained exactly the same. So let's run this program once again right now and check exactly what we have to the console. So first we have this hello, and we have a hash code, which is this one, and this is basically this first hello, and the hash code is still the same. Now afterwards, when we did this, str1 is still equal to hello, and the hash code is still exactly the same as previously. And in fact, here we see that when we printed str2, we have a different hash code. And let's optimize this a little bit in order to see exactly how this changes. Let's also, for instance, do a console write line after we declare str2 and make it equal to str1. So if we run the program right now once again, let's go through what we have and let's interpret it. So first we have the first string, which is hello, and it has this hash code. Then we declared str2 equals to str1, and we printed this to the console. So logically we have hello as output, and we have a hash code that is equal to the first one. So we can see here that str and str2 have exactly the same hash codes. However, after we performed this step, when we assigned a new value to str2, what happens is that when we print these strings to the console, we still have here hello for the first string with the exactly same hash code, but for str2, which now holds world, we see that we have a total different hash code, which means that now it is a total different object. So in this first time we printed out str2, it had the exactly same hash code as str1, but last time when we printed str2, it had a different hash code. And this means that the object itself changed, or the reference to the object itself changed. And this might be confusing because we saw a similar behavior in the case of value types. And in fact, if we declare integer number1 equal 5, then let's console write line, and we write number1 to the console, and let's also print the hash code. Let's copy paste again, and once again, I don't encourage you to copy paste code, but for demo purposes I think that is easier like that. And get hash code method, so that we can get a hash code. And you will see that the hash code for integers is slightly different than the hash code for strings, but that's also a very interesting thing to note here. Let's now here also declare an integer number2, and this would be equal to number1. And let's also, in this case, let's take the entire block of write lines, and let's write line also this here, and it will be here number2, and of course it will be also here number2 with the get hash code. Now let's make number2, let's give it a little bit more space. Number 2 equal 10. Okay, good. So we have a new value for number 2. But right now, let's try to add a bunch of console write lines here once again. So first of all, we want once again to write line the number 1 with the hash code, and also of course number 2, including then the hash code. And what we will see here, let's run the program and check it out. So it takes a while. Okay, so right at the beginning, okay, I put this in the middle between these console write lines. Let's take everything that we did with integers and cut it out from here and put it not in the middle but exactly after our operations and write lines that were performed on the strings earlier. Okay, and let's run it again, and now I think we should have a better understanding. And in fact, yes, we have here the first part which was with strings, and then we have here the part regarding numbers. And this is in this case a little bit more complicated, because as we see, the hash code in case of integers is the value of the integer itself. But let's try to interpret it. What happened here? So what happened here is that first we console write line number 5 and then the hash code. So this was number 1, and the hash code and the value in this case is the same. Then we have created here int number 2 equals to number 1, and in this case we see once again that the value is the same, and the hash code, since it is the same value, it is also the same hash code. So this is specifically one example in which you cannot use hash codes to see if these are really different objects. However, we know exactly that value types are different objects because they hold the exact value again. Now, last we did then once again print number 1, which remained still 5, and the hash code was still 5. And then when we printed the number 2, in this case it changed to 10 and 10. But as you can see, number 1 remained exactly the same. So that's why we can notice here a very similar behavior. So we have here exactly the same hash codes, and here we have once again the exact same hash codes until last time when we changed the value of integer. And that's what is causing the confusion, because of course somebody when tries this out, it would say, hey, but they behave really similar. So the string in this case is very similar to the integer. And the answer is of course no, this is wrong. Strings are still reference types, and integer is still a value type. And as we know, and I want to underline this once again, reference types hold as value a reference to the memory location where the object itself is stored, while the value type hold as value the value itself. So yes, although this might be very confusing right now, please make a note that string is a class and therefore a reference type, and integer is a struct and therefore a value type. And even if we see similar behavior when we declare and instantiate a string and an integer, really they are not the same. And even if we perform the same operations that we performed now on strings and integers, even if we see similar outputs, still strings are a reference type because string is a class. So that's everything for now about strings and the common misconception and misunderstandings on what strings really are and how they behave. I hope I was able to bring a little bit more clarity into this issue and into this topic. And if you enjoyed this video, then please feel free to hit the subscribe button. It would be very useful for me, because then I can know exactly if you liked it. And it would be also very useful for you, because you would get notified each time Developer Ramp Up has a new video for you. And also don't be shy and hit the like button and hit me with your comments, because comments are also very useful. You can let me know what topics do you want to see discussed in the developer ramp up channel, or maybe you can, let's say, maybe you see some things that I explained wrongly and then you can correct me, so it's not a big deal. I'm always open to that. And also it's a way to show your appreciation towards the content that I am creating. And also please feel free to share this content on your social networks, especially if you might have friends or some other people in your network that want to become a software developer that didn't study computer science, and I think that this content might be really useful for them, so feel free to share it. Thank you very much for watching this video, and until the next time, I wish you the very best.